Good morning.
Good morning.
How are you today?
Good. How are you?
Good. Well, did you have a good weekend?
Yes, it was pretty good.
So what'd you get into?
I went over to South Boston Speedway Saturday. They had open practice, so I watched them practice all day long.
Oh, you like racing,
And
huh?
then, yes, I
That's
love it.
cool. You didn't watch
And
any
my grandpa,
basketball?
no, not at all. My grandpa works over at the Speedway, so gives me another excuse to go over there all the time.
You bet. Good deal. Um, I had an interesting weekend myself. I lost water again. I have a guy up there trying to. He dug out my spring Friday and found it and put a new spring box in. Hopefully that'll be solved now. I hope. But the interesting thing was, other than the panic over the spring not running and rerouting, a buddy of mine called me. He's a horse trainer. He's in that Mustang makeover. Have you heard about that?
I heard you mentioned it last week, I think, though, but I hadn't heard it before then.
Okay, well, you can apply to be, in this competition, and they assign you a Mustang, and you have 90 days to get it as far trained as you can, and then you compete against other people. It's like they'll have a group of however many people and a competition set, and you apply to be a trainer or to be in it. And if you meet the qualifications and everything, they'll say, okay, all these trainers come pick up their horses these days. You have 1 or 2 days depending how big the group is, and they assign you a horse, and you pick it up, you go home, you got 90 days to get it ready for the show or for the competition. And so to demonstrate how well you can get it broke in 90 days. And the winner of this competition is like $4,000, and then they sell the horses after the competition, and you get half of whatever the horse brings over $200. So he's hoping for a pretty good paycheck. So I wish him luck. But we went out there. We drove out to Ewing, Illinois, picked it up Saturday morning, and turned around and drove back. So it was a long weekend in a truck, and we alternated driving, and it wasn't too bad. Having somebody else in the vehicle makes it tend to go easier, you know. You have somebody to talk to. But it was a good little deal. We had fun. I guess as much fun as you can have sitting in a truck and driving for about 9 hours. And we stopped at a hotel Friday night, and stayed Friday night, and then Saturday morning got up early, went to the pickup point, loaded up, and drove home. I guess I got home about 2 o'clock Sunday morning. Uh, that's all right. Uh, it was interesting. Got to see some new country. I hadn't ever been out there before. Out there, part of Illinois where we were at, lots of cornfields, very rolling, very big fields. It was different country. It's pretty. So that's always a good thing. I like to see agriculture in other places, and look at the landscape. All right. I told you we'd have an exam pretty soon. Um,
Yes.
we haven't really gone over. I mean, we've gone over some stuff, but uh, I need some more test material. Because the first exam was on body condition, nutrition, forage management, And what we've done now is really gone over some production goals. And I really don't know what to ask on that. I was trying to incorporate things for your project, some realistic goals, and to help you out with that. And we've talked about genetics, and I've got some genetic questions, uh, but I want to talk, I guess go over reproduction, and then we went over the economics. Now, I really don't know how to ask you questions on that. How to figure up your cost of feed, how to figure up your vaccines. And I looked over your plan, your health plan or the stuff you turned in. You're doing a really good job on that, Jasmine. You've got your,
Thank you. I was kind of worried about it.
you know, uh, you got to not, you've done your rations like I've asked you. What else do you turn in? Your forage, your forage management plan. You turned in your health too, didn't you?
Yes.
Did you have any economics in there or not? I can't
Uh,
remember. I know you had
I don't
prices
think
for
so.
feed. What's that?
I think I just had the feed prices and
Yeah,
the vaccine prices.
yeah. I remember seeing prices. So you're going to need to, you know, finish that part up in reproduction and then have your maps and stuff of your farms. And I think you're going to be in pretty good shape. Give me an index of, where I can go to find it. You know, say like nutrition on page 5 and 6, 5 through 8, and you have all your rations printed out, uh, and your math. Your health would be on another page, or you got an introduction to write about your farm and stuff. So you've got, it's not as overwhelming now as it once was, is it?
Not nearly as overwhelming.
No, you've done your health, you've done your vaccine or your nutrition, you've done your uh, forage management. You're going to have to put together a genetic section. What are your breeding goals and stuff like that, and what are you going to select for in bulls and cows? Now you just doing a terminal cross, aren't you? You're going to sell all your cows, right? I mean, all your
Yes,
calves. You're not keeping replacements.
that's right.
Okay, so that you're going to be looking for, for carcass quality and weight gain. And one of those indexes, that we're looking at, for picking your bulls, or you don't have to pick out certain bulls, those change, but tell me the criteria you're looking at is that dollar beef index there. And that kind of gives the overall. And I was just reading an article about that this past week. Which one should you use? And they were talking about, they've talked about everything we talked about with genetics. But they said, the dollar beef that I think Simmental and Angus both have it, maybe some of the other breed associations. Um, it takes into account growth, and it takes into account meat quality. And they were saying that although, if you have, if you're selling your calves at weaning time, you may not get that money or realize that extra money from that dollar beef, using that dollar beef index, because the feeder is going to do that, when he sells to the packer and he sells them on the grid, he'll get that extra money. But at the same time, if he's making money off your calves, he's going to come back to you and be willing to pay you a higher price. Does that make sense?
Yes.
So, and then they were worried about if you just looked at dollar beef, would your cow size get bigger? And they said, well, it might, but if you're using that dollar beef, you're probably going to terminal sire. or a terminal deal, and you're not keeping any of your replacements. Everything just goes to the feedlot eventually into the plate. So, um, that dollar beef index may be a pretty good little uh, tool for you to use for selecting your bulls. Does it make sense?
Yes.
Okay. All right. So, what I want to talk about today then is reproduction. And um, what we're going to do today, I'm going to show you that video that we looked at in animal science. And what you need to look at, you need to know what I would do. I would make a list of these hormones and know where they originate from. What do they control? What's their target of action? So say, like, for instance, uh, progesterone. Progesterone is produced by the corpus luteum, which is found on the ovary. It's a structure that comes up on the ovary. And what it does is it maintains pregnancy. And it prepares the uterus for implantation, of of the fetus. So it prepares the uterus for pregnancy and it maintains pregnancy. And it keeps that cow from coming into heat. So I would know where the hormone originates, what's its purpose, and see what else I can think of on that. There were about 3 of them. The purpose, where it originates. And so you'll need to know, like, GnRH, FSH, LH, estrogen, progesterone, luteolase, not luteolase, I'm sorry, prostaglandin, testosterone, those are the ones that you'll be tested on. There's a few more involved, like oxytocin and relaxin. But those that I listed will be the main hormones you'll be using. You need to know how they work, because we manipulate those hormones, all but testosterone, to synchronize estrus. Does that make sense? All right, so let's watch this first video, and then we'll discuss it. Can you see me today? Yeah, I see you on the screen, so they must have got it.
Yes.
All right. Is that loud enough?
Yes.
How you like that music, Gil?
Successful artificial insemination programs are based on a clear understanding of the anatomy and physiology of reproduction in cattle. Before attempting to inseminate cows, you must develop a mental picture of the anatomical parts that make up the female reproductive tract. In order to understand why an animal displays.
All right, the other thing you need to know is the anatomy. So you need to know the anatomy of a cow, the reproductive parts, because those hormones are produced by those structures. Okay?
Okay.
If you need me to pause it, let me know and I'll pause it for you.
The many signs of estrus, when she should be inseminated, and how the pregnancy.
And the other thing you want to watch out for in here, what are the signs of heat? What are the signs of estrus? Okay?
Okay.
That'll be another test question.
Develops, you must also clearly understand the hormonal mechanisms controlling the estrus cycle in cattle. First, let's look at the parts that make up the reproductive system in cattle. There are 2 ovaries, 2 oviducts, 2 uterine horns, a uterine body, the cervix, the vagina, and the vulva. The bladder lies below the reproductive tract and is connected at the urethral opening located on the vaginal floor. The rectum is located above the reproductive system. The vulva is the external opening to the reproductive system. The vulva has 3 main functions: the passage of urine, the opening.
And know the functions for the different parts, the anatomical parts.
For mating, and.
Oops, sorry, I went too far. I'll start up over again and be quiet. Unless you have a question, then I can pause it.
Successful artificial insemination programs are based on a clear understanding of the anatomy and physiology of reproduction in cattle. Before attempting to inseminate cows, you must develop a mental picture of the anatomical parts that make up the female reproductive tract. In order to understand why an animal displays the many signs of estrus, when she should be inseminated, and how the pregnancy develops, you must also clearly understand the hormonal mechanisms controlling the estrus cycle in cattle. First, let's look at the parts that make up the reproductive system in cattle. There are 2 ovaries, 2 oviducts, 2 uterine horns, a uterine body, the cervix, the vagina, and the vulva. The bladder lies below the reproductive tract and is connected at the urethral opening located on the vaginal floor. The rectum is located above the reproductive system. The vulva is the external opening to the reproductive system. The vulva has 3 main functions: the passage of urine, the opening for mating, and serves as part of the birth canal. Included in this structure are the lips and the clitoris. The clitoris is analogous to the penis in a male animal. The vulva lips are located at the sides of the opening and appear wrinkled and dry when the cow is not in heat. As the animal approaches estrus, the vulva will usually begin to swell and develop a moist red appearance. The vestibule includes the vulva and the interior portion of the reproductive tract extending forward to the urethral opening. The vagina, about 6 inches in length, extends from the vestibule and urethral opening to the cervix. During natural mating, semen is deposited in the anterior portion of the vagina. The vagina will also serve as part of the birth canal at the time of calving. The cervix is a thick-walled organ forming a connection between the vagina and uterus. It is composed of dense connective tissue and muscle and will be our primary landmark when inseminating cattle. The opening into the cervix protrudes back into the vagina. This forms a 360-degree blind-ended pocket completely around the cervical opening. This pocket is referred to as the fornix. The interior of the cervix contains 3 or 4 annular rings, or folds. This design by Mother Nature facilitates the main function of the cervix, which is to protect the uterus from the external environment. Learning to manipulate the cervix and the cervical rings over the insemination gun is the primary obstacle for the beginning inseminator. The cervix also functions as a barrier to sperm transport after natural mating. This results in a filtering of abnormal sperm cells from the ejaculate, allowing only the fittest to continue toward the site of fertilization in the oviducts. Because we can bypass the cervix and its barriers to sperm transport, only a fraction of the number of sperm cells are required for normal fertilization rates with AI, as opposed to natural mating. The uterus and lower portion of the oviduct also filter abnormal sperm cells in both natural and artificially serviced animals, again resulting in only the fittest sperm competing for fertilization of the egg. The cervix also completes the final segment of the birth canal. At the time of calving, the cervix dilates in response to the hormone relaxin, allowing uterine contractions to expel the calf. The cervix opens anteriorly into the uterine body. About an inch long, the body of the uterus serves as a connection between the 2 uterine horns and the cervix. The uterine body is the site where semen should be deposited during artificial insemination. From the uterine body on, the reproductive tract separates and all further structures come in pairs. The 2 uterine horns consist of layers of muscle and a heavy network of blood vessels. The main function of the uterus is to provide a suitable environment for fetal development. When a cow is bred, either naturally or by artificial insemination, the uterine muscles, under the influence of the hormone oxytocin, rhythmically contract to aid in sperm transport to the oviducts. Oviducts, as their name implies, carry ova, the cow's eggs. The oviducts are also commonly referred to as the fallopian tubes. The oviduct has several distinctly different regions when examined microscopically. The lower segment, closest to the uterus, is called the isthmus. The connection between the uterus and the isthmus is called the uterotubal junction, or UTJ. The UTJ functions as a filter of abnormal sperm, and the isthmus as a reservoir for healthy sperm. Research suggests that upon gaining access to the isthmus, healthy spermatozoa attach themselves to the walls and wait for a chemical signal that ovulation has occurred before continuing on to the site of fertilization. During this period of attachment, many physiological changes occur to sperm membranes, which are essential to attainment of fertilization potential. These changes are collectively referred to as capacitation and are apparently regulated by this very important attachment to the walls of the isthmus. It takes about 5 to 6 hours after insemination before a sufficient number of fertile sperm cells can populate the isthmus and complete the capacitation process. The upper portion of the oviduct closest to the ovary is referred to as the ampulla. The interior of the ampulla is more open than the isthmus, allowing for easier passage of ova. It is within this segment of the oviduct that fertilization actually occurs. It is believed that a chemical signal released at the time of ovulation stimulates the release of spermatozoa from the walls of the isthmus, allowing them to continue their journey to the site of fertilization in the ampulla. Ova are recovered by the large open end of the oviduct, which surrounds the ovary. This funnel-like structure, called the infundibulum, keeps the ova from falling into the body cavity. Hair-like structures on the infundibulum and within the ampulla carry ova and a surrounding mass of cells called the cumulus mass down the oviduct to the site of fertilization. For reasons unknown, the cumulus mass is apparently very important to ovum transport. Glass beads, or ova without a cumulus mass, simply rotate in place on the ciliated cells and are not actually transported. The ovaries are the primary organs in a cow's reproductive tract. They have two functions, to produce eggs and to produce hormones, namely estrogen and progesterone, throughout.
All right, that's going to be a test question. What's the two functions of the ovary?
Throughout the different stages of the estrous cycle. On the surface of the ovary, you will usually find two distinctly different types of structures. Follicles are fluid-filled, blister-like structures that contain developing oocytes, or eggs. Usually, you'll find numerous follicles on each ovary that vary in size from barely visible to ones 18 to 20 millimeters in diameter. The largest follicle present on one of the ovaries is termed the dominant follicle and is the most likely candidate for ovulation when the animal comes into heat. Over time, greater than 95% of the other follicles on the ovary regress and die without ovulating and are replaced by new crops of growing follicles. The other structure found on the ovarian surface is the corpus luteum, or CL. The CL is the site where ovulation occurred during the previous cycle. Unless there were twin ovulations, you should find only one CL located on one of the two ovaries. The CL will usually have a distinct crown protruding from the ovarian surface, which facilitates identification during rectal palpation. The CL may also have a fluid-filled cavity, but usually has a much thicker wall than a follicle, and thus a much denser texture when felt by palpation. Corpus luteum is Latin for yellow body. While the outside of this structure is usually dark red in appearance, a cross-section reveals a bright yellow to yellow-orange interior. Those are the parts of a cow's reproductive tract. Now, let's see how the hormonal system works. Over a period of time, many changes take place in the reproductive system in response to changing hormone levels. These changes in non-pregnant normal females repeat every 21 days. This regular repetition is called the estrous cycle. Let's discuss how the estrous cycle works, starting with a cow in heat on day 0. Looking at the reproductive tract, we see several things happening. One ovary has a large follicle, approximately 15 to 20 millimeters in diameter. This follicle has a mature egg inside, ready to be released. The cells lining the follicle are producing the hormone estrogen. Estrogen is transported in the bloodstream to all parts of the cow's body, causing other organs to react in a number of ways. It makes the uterus more sensitive to stimulation and aids in the transport of semen at the time of insemination. It causes the cervix to secrete a viscous mucus that flows and lubricates the vagina. Estrogen is also responsible for all signs of heat, including a red, swollen vulva, allowing other cows to mount her, going off feed, bellowing considerably, and holding her ears erect are but a few of the many signs.
You need to write those down, the signs of heat. Red, swollen vulva, holding ears erect, allowing other cows to mount her, bellowing, going off feed. Hopefully this will be recorded for you so you can watch it again. Okay, you got them down?
Yes.
On day 1, the follicle ruptures or ovulates, releasing the egg to the waiting infundibulum. Several hours prior to ovulation, estrogen production declines. As a result, the cow no longer displays the familiar signs of heat. After ovulation, new types of cells called luteal cells grow in the void on the ovary where the follicle was located. Quite rapidly over the next 5 to 6 days, these cells grow to form the corpus luteum. The CL produces another hormone, progesterone. Progesterone from the CL prepares the uterus for pregnancy. Under the influence of progesterone, the uterus produces a nourishing substance for the embryo called uterine milk. At the same time, progesterone causes a thick plug to form in the cervix, preventing access of bacteria or viruses into the uterus. Progesterone also prevents the animal from returning to estrus by blocking the release of follicle-stimulating hormone from the pituitary gland in the brain. Follicle-stimulating hormone, or FSH, as its name implies, stimulates the growth of follicles. Rapid follicle growth usually results in estrogen production, which would bring the animal back into heat. This would make life difficult for a new embryo if she were pregnant. Thus, progesterone's block to FSH is a very important aspect of maintaining the pregnancy. On the other hand, if we did not breed the cow, we do want her to come into heat again. Days 16 through 18 of the estrus cycle are referred to as the period of maternal recognition. During this time, the uterus searches itself for the presence of a growing embryo. If no embryo is detected, the uterus begins to produce another hormone called prostaglandin. Prostaglandin begins to destroy the CL. When the CL is destroyed,
You need to pause it again?
No.
Okay. So prostaglandin's produced in the uterus, and it destroys the CL.
no
I
more
got it.
progesterone is produced, and the pituitary gland begins to secrete FSH. This rise in follicle-stimulating hormone initiates the selection of a new follicle to grow to a large size, produce estrogen, and bring the animal back into estrus. A full cycle is now completed. The average total time is about 21 days. The estrus cycle is subdivided into 2 phases based on the dominant hormone or ovarian structure during each phase. The luteal phase begins when the corpus luteum is formed, about 5 to 6 days after the cow was in heat, and ends when the CL regresses, about day 17 to 19 of the cycle. Progesterone levels are high during this phase of the cycle, and estrogen levels are low. The other phase of the cycle, the follicular phase, begins when the CL of one cycle is regressed and ends when the new CL of the following cycle is formed. Thus, the follicular phase encompasses the period of time surrounding estrus. During this phase of the cycle, estrogen levels are typically high, while progesterone levels are low. As mentioned earlier, follicles may be present on the ovaries throughout the estrus cycle. Research using ultrasound technology has characterized follicular growth as occurring in waves. Normally, an animal will have 2 or 3 waves of follicular growth during a 21-day cycle. The beginning of each wave is characterized by the rapid growth of numerous follicles. From this wave, or crop of follicles, and by mechanisms still unclear, one follicle is allowed to grow to a much larger size than the others. This large follicle is referred to as the dominant follicle, as it has the ability to regulate or restrict the growth of all other follicles on the ovary. Dominant follicles only remain dominant for a short period of time, 3 to 6 days, which is followed by cell death and regression. Consequently, disappearance of the dominant follicle coincides with recruitment of the next crop or wave of follicular growth. From this new wave, another dominant follicle will be selected. Although it is typical for much follicular growth to occur throughout the estrus cycle, low levels of FSH during the luteal phase, when progesterone levels are high, prevents these follicles from producing high levels of estrogen, which would bring the animal back into heat. It is only the dominant follicle present at the time the CL regresses and when progesterone levels are low that is permitted to produce enough estrogen to bring the animal back into estrus and to continue on to ovulation. Let's follow the events that occur after insemination. For the first 4 to 5 days, it would move in the oviduct toward the uterus. Once the egg gets there, it will be bathed in uterine fluids and continue to grow. While floating free in the uterus, several membranes, including the amnion, the chorion, and the allantois, are produced by the new embryo. Collectively, these membranes are referred to as the placenta. Hopefully, by the time the period of maternal recognition arrives, days 16 through 18, the fetus and growing placenta will have produced adequate quantities of the chemical signal required to maintain pregnancy. This chemical signal interferes with the action of prostaglandin on the corpus luteum. The CL is thus retained and continues to produce progesterone, which is essential to maintenance of the pregnancy. At about 30 days of gestation, the placenta begins to attach to the uterus at several points. The placental side of these attachment points are called cotyledons, while the uterine side has caruncles. The attachment of cotyledons to caruncles is very similar to Velcro. This greatly increases the surface area within the attachment point. Surface area within attachment points is important to allow for exchange of nutrients and waste products between calf and mother by way of arteries and veins leading to and through the umbilical cord. At calving, the muscles in the uterus begin to contract and eventually expel the calf and membranes through a dilated cervix and vagina. Several hormones, including progesterone, estrogen, prolactin, relaxin, and corticoids, produced by the mother, the fetus, and the placenta, interact to bring about this event. Calving in a clean environment and proper treatment of the cow after a difficult calving will help prevent reproductive problems. Becoming familiar with the reproductive anatomy and physiology of a cow will help you do a better job artificially inseminating your cattle. Understanding how the hormones involved in the estrus cycle interact to control this phenomenon gives you clearer understanding why and when animals display the many signs of estrus, how pregnancy is maintained, and of what you or your veterinarian must do to treat cows who don't cycle normally.
Okay, on in the reproduction folder, there is I do have some literature that explains all this. So I would recommend you to read that. Okay. Uh,
Oh,
Now I've got a lot of stuff up here in that. Uh, Now in try to get back. I lost my thing here. So that covered. I think that does a really good job explaining the reproduction cycle. And you know that there's hormones and the anatomy. I think that video just does a grand job with that. And these other publications up there, I got on Blackboard will help you to understand it further. So I'd recommend you to read that one I just showed you, and then ask me what questions you want. Now, when it comes to horses and sheep and goats and pigs, dogs and cats and rabbits and even people, those hormones are the same. I mean, species, they're specific for species, but they're all there. And that reproduction cycle works very similar in all mammals. There are species differences, um, such as the length of the estrous cycle, length of gestation, uh, the way the placenta attaches. Uh, but basically, those hormones, and those functions of the hormones are the same across species. So, you know, sheep, their estrous cycle is about, I think it's 16 days, but you still have those same hormones. And so we can manipulate those for synchronization in sheep. Horses have those same hormones, uh, but their estrous cycle is a little bit longer. And one thing that's unique with horses is that they will breed back on what's called foal heat. After about 10 days after foaling, they'll come into heat and they will be fertile. Uh, Cattle don't do that, and I don't think sheep does that. Pigs, uh, once you wean off that litter, they'll start coming back into heat, and usually you wean in about 21 to 28 days is what the industry does now, uh, for weaning those pigs. Any questions you have on those hormones or the anatomy and physiology?
Did the video mention the GnRH? Because I don't think it did.
Okay, I I'm thinking it did, but if it didn't, this next video I think mentions it. GnRH, and it must not have, if you're asking that. GnRH is produced in the hypothalamus, and the hypothalamus is one of the structures in the brain, one of the lobes in the brain. And GnRH stands for gonadotropin releasing hormone. And so GnRH, it's produced in the hypothalamus, and it acts on the anterior pituitary gland. And the anterior pituitary gland, because the pituitary gland's got an anterior part and a posterior part. But the pituitary gland produces FSH, which is follicle stimulating hormone, and LH, which is luteinizing hormone. And GnRH regulates the release of FSH and LH. So back, in the luteal phase of the cycle, when the corpus luteum is producing progesterone, you remember how the video said that when progesterone is high, FSH is not released? Okay, you have that block there. It actually is released, but it is released in a very slow fashion. It's a tonic fashion, like it's a drip, 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 drip. And because that progesterone blocks the release of the GnRH, which blocks the release of FSH or inhibits that release of it. So it's released very slowly and at minute levels. But when that progesterone's gone and that block, when progesterone's gone and it's not saying, hey, don't release GnRH, when that's gone because of because of the prostaglandin knocks out the Cl and it's no longer there, it's saying, okay, we got to get bred again. So that progesterone's not inhibiting the GnRH release, so it's telling the pituitary to release more. It's being released more, and the pituitary is dripping that GnRH is going to the pituitary, and it's going drip, 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 really fast. And as that, here, let me put up this drawing I have on here. Now this is my drawing. And I'm going to tell you right now that I am not an artist. Okay? So this is in that reproduction deal. So what we have is, this here is the hypothalamus, the brain, and the hypothalamus in it. And it releases GnRH.
Half of the picture is cut off.
Oh, I don't know what to do to help you. I don't know how to change it. That's not good. All right. I don't know how to change that. What can't you see of it? Can you see where my arrow is here?
No.
Huh. It's showing up on mine, but I don't know how to center that up. But I'm trying to see what I can see on your screen of it. You don't see the little circle where I have brain, hypothalamus written on it?
No.
Okay. And you don't have your computer to pull it up?
No, I didn't bring it
There's
today.
pictures you can pull it up. Okay, I'm sorry. If you can imagine up here in the left-hand corner, I just have an oval shape. I have brain written in there with a hypothalamus. And the hypothalamus, I have an arrow drawn down to, with GnRH. It produces GnRH. The GnRH, I have an arrow going over to the right, over here to the pituitary gland. Can you see this here?
Yes.
Okay. So this is the pituitary gland. Now in real life, the pituitary gland it's dubbed the master gland because it produces so many hormones that regulate our metabolism, our heat, our internal body temperature. It regulates our growth. It regulates reproduction. It helps regulate our heartbeat. It regulates so much. And it was thought at one time that if you lost your pituitary gland, you would die. That possibility still exists today. However, with modern medicine, we have other hormones, or we have synthetic hormones that we can administer to people to help regulate body temperature and metabolism and body heat and heartbeat and so on. Does that make sense?
Yes.
It's a very important endocrine gland. So the pituitary gland, the hormones that it produces a lot of hormones, as I said, with a couple of them producing LH and FSH. The other reproductive hormones or hormones within the reproduction deal it produces is oxytocin and relaxin and prolactin. And oxytocin is dubbed the milk letdown. So like when a calf balls it and it starts pushing on that udder for that cow because it's going to nurse, it causes release of oxytocin, which causes milk letdown. So like in dairy cows, there's two reasons why you wash the udder of that dairy cow before you milk it. One is sanitary reasons. Keep it from being mastitis, keep it, to prevent mastitis, and also to stimulate that action of that calf of playing with that, of, messing around with that uterus to release oxytocin, which causes milk letdown. So there's a physiological and hormonal reason why you wash the uterus or wash the udder prior to milking. It's just not sanitary. Sanitation's a big one. We like to drink clean milk and don't like to have a drink of milk with some dried fecal matter in it or mud. So, a couple purposes. Relaxin causes those muscles to relax prior to calving, those hip muscles and those ligaments and everything for that calf to come out. But anyway, the pituitary gland, the two hormones we're worried about in the estrous cycle is LH and FSH. And that's released together, just that drip, 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 drip deal. And it acts on the ovary. Now, when the progesterone when the corpus luteum is present and is producing progesterone, it blocks the release of, it inhibits the release of GnRH. And so it's that drip, 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 or drip, 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 drip deal. And we know that FSH stimulates follicular growth and those cells around the follicle that produce estrogen, correct? So when the corpus luteum recesses, either through prostaglandin produced by the uterus or we give them a shot of prostaglandin, that negative feedback's no longer there. And so it starts getting, FSH is released really fast through here. Boom, boom, drip, 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 drip. The more FSH it's produced, since it stimulates it's a follicle stimulating hormone, it's that dominant follicle, or the follicle that's the biggest becomes the dominant follicle. It's taking all that stuff in, and it's growing very, very rapidly. And all those cells along that, in that cumulus mass, it's taking that in as well. It's producing a whole bunch of estrogen. That estrogen gets high enough, the cow starts demonstrating signs of heat or signs of estrus. With that red swollen vulva, standing to be mounted, bellowing, walking around, ears erect, going off feed, being restless, allowing cows to mount her. And that gets, as that gets higher, she starts showing those signs. Well, it reaches a point, there's a cutoff switch when it gets a certain high, when it gets to when the follicle and that cumulus mass is producing a certain amount of estrogen, it flicks this switch and says, hey, I'm ready to be released. The GnRH says, hey, or the hypothalamus says, hey, let's dump some more GnRH on here and get this thing out here to get bred. So it tells the pituitary gland more, faster, and it gushes out of LH and FSH. It just goes whoosh, a big dose of it. And that LH that's released during that time causes that big gush of LH causes that follicle to be released from the ovary. And as soon as that's released, then those luteal cells start growing. Does that make sense?
Yes.
Okay, good. Let me see this other picture I got here. So, is this picture cut off too?
A little bit, but I think I can see most of it.
All right, so this is color coded with different hormones. It kind of shows the different hormones throughout that cycle, the rise and fall of those hormones with LH and FSH, progesterone, prostaglandin, and estrogen. So you can look at that. May help you out. So, do I have you more confused, or we about right?
No. I understand
The
it.
water's pretty muddy.
I understand it.
All right. Understanding it's the first part. You got to understand how it all works. And then you got to know it for the exam. You didn't want to hear that. You didn't want to hear that part, did you? So, don't be afraid to call and ask questions. All right?
Okay.
So, now, the second video I'm going to show you is called estrous synchronization. And the take-home message, or what I want you to pay attention to in this video, is how we use GnRH and progesterone and prostaglandin to manipulate synthetic deals of GnRH and prostaglandin and progesterone to manipulate the estrous cycle. So if we have a herd of beef cows, we can utilize these drugs in different combinations in order to get all these cows to come into heat fairly close together so we can synchronize them, or so we can AI them all about the same time. Does that make sense?
Yes.
So they're going to go over a bunch of different protocols on how, they're going to show you a bunch of different protocols on here on how, timing of using these drugs, and using 2 drugs or using 3 drugs. They're going to talk about all that. I'm not going to ask you about these protocols. What I would ask you is, how do these, what does progesterone, why do we use, if you got a herd of beef cows or sheep, what hormones are you going to use to synchronize these animals, and why? What do these hormones do? What does prostaglandin do? Why do we give them progesterone? Why do we give them GnRH? Does that make sense?
Yes.
All right, and this video should explain it. So I think we've got enough time to watch this video. Actually, we don't. It's about 30 minutes, and we've only got about 15 left to go. So let's do this video on Wednesday. Is that all right?
Okay, that's fine.
Well, I guess we have much of a choice, do we?
Not really.
since we don't have enough time to watch it. But it wouldn't have done us any good to watch that video if you don't understand all of this. So, what questions do you have regarding the estrus cycle? Okay, let me show you. Right here is another picture of that one drawing I tried to make. Now, these round figures here, this is the growth of the follicles. This blue line here is progesterone. This red is prostaglandin. So, as we see, day 0, when she ovulates, we see that that progesterone is really low. And as this I'm sorry, this is not follicles, this is the corpus luteum. This corpus luteum is growing, but it's not functional yet. And about day 8, 9 or so, it's pretty functional. But, as it's growing, I shouldn't say it's not functional yet. It's not functioning to the best of its ability yet. It is producing progesterone. You see this progesterone level start to increase. And as we get up into day 12, day 14 of that estrus cycle, corpus luteum is pretty big on day 14, and that's about when that progesterone level peaks out. Now, if you remember from the video, day 14 to 16 was that maternal recognition period, right? That fetus produces a hormone that says, hey, I'm here. Don't get rid of me. And what happens is that hormone blocks prostaglandin, and this corpus luteum will continue out the length of gestation. Make sense?
Yes.
But if that cow's not pregnant, that fetus, there's no fetus in there or no embryo in there to produce that hormone. And so the uterus produces or releases prostaglandin. And that prostaglandin makes that corpus luteum to start to regress and causes it to regress. And then progesterone production drops. And when that drops, that FSH increases. Remember? Drip, 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 drip. So, now in real life, sometimes that fetus or that embryo is not viable or healthy, and it doesn't produce enough of that hormone, and that cow aborts. We don't even know it. She just comes back into heat and hopefully gets bred when she comes back in and carries. But sometimes there's abortions right through here because that embryo is not stout enough to produce that protein to block, or that hormone to block prostaglandin. Now, if we scroll down, again, that's progesterone and prostaglandin. This is a follicle stimulating hormone. You have those different rises, those different phases of follicles, but they just don't they just start regressing because that progesterone's blocking FSH. But when it's gone, that last one will start to mature and be the one that's ovulated. On that last regression, there's about 3 waves during an estrous cycle. 2 to 3 waves. Some 2, some 3. So anyway, see, there's your follicular waves. You have a wave, another wave, and then this one. The healthiest one will be in that third wave will become your dominant. So you can look at that. This is how this is just a drawing of the hormones, the different rises of them. This maroon line is estrogen. You see it's high there at estrogen, or day 0, and it just drops. And it's really low. As it's dropping, progesterone starts to increase from the corpus luteum. Prostaglandin comes in and knocks it out. When it's gone, estrogen gets real big, starts increasing again. And LH will shoot right up here too. You'll have that LH surge right before ovulation. If LH was on here, it would be up here right before that egg's released. So, any questions regarding that?
No.
Now, if the other thing we're going to talk about, we spend a lot of time talking about the cow, but we can't forget the bull. It takes 2 to tango, right? So, we'll talk about the bull as well, because we can have the best repro management on our cows, but if our bull is not producing semen, and we're not AI, and we're not going to get our cows pregnant, are we? So you can't ever dismiss the bull end of things. So we'll talk about that. We'll talk about synchronization drugs. And I do have stuff up here, repro management of sheep and goats and pigs and horses for the online horse students. And so I got your stuff up here that you need. You have any questions for me? Say yes. We got 10 minutes.
I can't think of any.
Okay. That's fair enough. So, I kind of had planned to do those 2 videos today. But I started talking and we ran out of time because, one's 24 minutes and one's 20 minutes. But we kind of did our normal chit chat prior to class. So I ran out of time on that. And that's my problem. That's not good preparation. But at the same time, too, it might have been information overload for you. And that can be just as dangerous as not giving you any information because you're so overwhelmed you didn't pick up any of it. Right?
All right.
You don't sound very convincing on that. So, Jasmine, and you online students, this should be on the recording. So, if you need to watch it again, watch it again. Look over those extension publications, and and digest it for a couple days. And Wednesday we'll talk about how we can manipulate those hormones or use those hormones to manipulate the estrous cycle. So, um, did I tell you? I don't know if I told you this or not. Uh, Back in animal science, if I did, you'll just have to bear with me again. Now, you know how I told you that these hormones are, and the cycle works across species. You know, different species, they still have these same hormones. They're just species specific. But, and there's differences in the cycle, but it works all the way. Um, my sister was unable to have kids. And, but she was trying anyway, her and her husband. And so she was telling us about going to this fertility doctor. And so I told her, I said, okay, first thing they're going to do is give you birth control for progesterone. And she looked at me funny and she said, okay, he did. Why? I said, because you got to have progesterone in there, get the whole system primed up. I said, after that, you know, what he's going to do is to see if you can get pregnant. That doesn't work with the extra progesterone. Then he's going to come in here, more than likely, and do GnRH. And GnRH is going to cause, remember what GnRH does? It releases
It
FSH,
releases
right?
yeah.
Right. So he's going to come in there with either GnRH or FSH, and that's a protein hormone, so you're going to have to take shots every day. And she looked at me like, yeah, right. Like, okay, it's all right. And so anyway, time went on. She calls me up one day. She said, I just got back from a doctor, and you know, the birth control with this progesterone deal you're talking about just didn't work. So we're talking about our next options. And all that stuff you told me, you were right. That I'll have to take shots. Let me ask you this, Dwayne. How do you know this? I said, sis, what's my master's degree in? She said, reproduction in cows. I said, okay. Hormones in cows are the same in people. This is the kind of stuff we do with cows all the time, especially if we're going to superovulate it. We're going to give that cow FSH so that she produces more than one follicle when she ovulates. And she looked at me, there was hesitation on her. You know, there was just hesitation on the phone line. So the doctor was going to superovulate me, and I said, yeah, pretty much so. You know, these people that have octuplets and stuff like that, they're taking fertility drugs. That's very unusual in nature. So, yeah, you know, and he might not have, you know, they might not have, you know, if you ovulated all those, they might have collected them and froze them to implant you at a later date if you wanted more kids. But yeah, he was going to increase his chances of you ovulating more than one egg. So these hormones are the same for people or cows. So you know, those premises are the same. I just thought that was a kind of a funny story. And then my wife, she's a physician's assistant in dermatology. And so I can't remember the specifics of this one incident, uh, but she called me asking me something about nutrition and hormones uh, because of the patient she had, and she thought it might have been the rash or whatever the patient had. I don't remember the specifics, but I was thinking. I told her, I said, I think it's a lack of a certain nutrient, and I don't remember what it was. And I said, look it up. I said, no, I'm not a doctor by any means, but this is what I think it could be. And she looked it up and stuff, and she called me back. She said, I think you may be right. Let's wait for the pathology results, and I got to talk to my boss and see what's going on. So, turned out that I was right. That doesn't happen very often, and I'm sure that's hard for my wife to say, hey, honey, you're right. What is it with you women? You hate for your man to be right. So, nutrition and reproduction, it's very similar across species, people. It's important. That's why I pound on it. And you're not going to have cows aren't going to get pregnant if you don't feed them right. And hopefully I pounded that into your head with body condition and how important that calving and good body condition is. So anyway, all right. Well, I think we're out of time now. So let's get back. I got to go back and meet my spring guy, see what he did to my spring, and he's got his excavator up there, so I'm got to get him to do some other work for me while he's there. So, Jasmine, you have a good rest of the day. When do they start racing there at South Boston?
Saturday is the first race, but
is it a dirt
I'm gonna have
track?
to miss it.
Uh-oh.
No,
you have to work.
They just paved it this past year, so
okay.
The first time people were really running on it was this past Saturday at practice.
Were there a lot of wrecks?
No, one guy blew an engine, but he said he'd have it ready by next Saturday.
Oh,
but I'm
sure
going out of town. I'm going out of town with my church group, so I'm going to have to miss it.
Where are y'all heading to?
Greensboro to Winter Jam.
Okay.
But that morning I have to help the middle school with go-kart racing. They race on a dirt track right beside the speedway.
Now when is that? Down there in Greensboro?
No, it's Saturday morning at the track, and then I'm leaving straight from there going to Greensboro.
Oh, okay. Go-kart racing's fun.
Yes, it is.
The only time I've done that, I mean, I'm not a motorhead, and I'm not knocking anybody that is. Everybody has their own likes and dislikes and hobbies. But so I've never had my own go-kart to race. But my only experience with it is when I was out in Nebraska, there was a go-kart track nearby, and it was a slick track. It was flat, real smooth, and they go out there and they put wax on there, and it was slick. And so it wasn't really a race. You could just go out there and ride. But there was a group of us that went, and we raced. And they had a little nut there underneath the gas pedal, so it could only go so fast. But it was a 9/16. I think it was a 9/16 or 7/16 nut. So if you slipped a wrench in your pocket, And when they weren't looking, you could adjust that a little bit more so you could go a little faster. Not that I would do anything like that, you know.
Yeah.
And if they weren't looking and you're going around the curve on that little slick track, racing's rubbing, right? Rubbing's
Yes,
racing.
definitely.
They said in,
Definitely.
though Robert Duvall said in the movie, what was that movie? Days of Thunder. Rubbing's racing. You could rub them
Yeah.
a little bit there in that back bumper just right and spin them out and keep on going.
Yeah, I have my fair share of that because when I was in
Yeah.
7th grade, I was the first girl uh, champion at the go-kart track for the middle school.
Cool. Did you
Yeah.
have your own go-kart?
No, they have go-karts, but I was trying to talk my grandpa into getting me one, but he said they're too expensive.
Yeah, they're pretty pricey. But
And then I was trying,
go ahead.
I was talking him into getting me a small race car for like, it's called a Hornets division, and most of them drive like little Chevy Cavaliers and stuff.
Yeah.
And they get around the track pretty good too, but they're really rough on that division.
Well, you know, sometimes it's not all about the speed. You know, whether, you know, I mean, I know the cars are, you know, you got certain horsepower classes or divisions, you know. Sometimes it's about that driving and your driving ability and the ability of the other drivers out there. You know, sometimes speed doesn't, you know, watching a race from as a spectator sport, whether there's, you know, and I'm probably not a true spectator to appreciate, you know, you got to have the speed, you know, for all that speed, but it's maneuverability and bumping and grinding and positioning, you know, you know what I mean? I ain't gonna lie to
Yeah,
you. I like to watch the crashes as long as nobody gets hurt.
yeah,
I don't have a problem watching there and some guy's not getting out of the way and another guy's been riding his bumper for a while and hey, get out of my way and he tries to pass him and he blocks him. And you know that's understandable. So he kind of gives him a little nudge to get him out of the way and may spin him out, you know. But you know, at the same time, there's a respect there that that guy's been riding you, he's been racing you clean, and he's going to make the pass, and he's faster than you. You know, you got that respect. You know, if he gets up to a certain point on your car, you don't go in there and cut him off. You just let him have that position. You know what? You know what I mean? There's a fine line there with that respect and with racing. It's kind of like,
yeah,
you know, you hear the term a lot, the cowboy code, the code the cowboys live by and things that they do. Those racers have the same deal. Kind of that unspoken, the unspoken rules of the game
yes. They
that you
had a
just
big
have to learn by
controversy about
watching.
that last year.
What's
They
that?
had a big controversy. They at the cup level, they had a big controversy about the drivers and their unspoken rules and like unwritten rules, and because they were like bumping and spinning each other out and trying to get revenge and all that.
Well, you know, in reality, that kind of makes the spectators watch it to see what happens next week. You want some of that drama. You know, if you
That's
remember
one
back in
reason
the
I
days
watch
of
it.
Earnhardt, what's that?
That's one reason I watch it.
Yeah, I mean, you know, and you don't have it now in the cup like you used to. Or if it is, you know, I don't know. I mean, you knew Earnhardt, he's going to knock somebody out of a race. You knew Rusty Wallace was hot tempered. You knew, you know, uh, what's his name? drove the Kellogg number 5 car. Terry Labonte. You knew he was hot-tempered and he could drive. He'd give you respect, but if you tick him off, he's going to put you in the wall as well. Earnhardt just put you in the wall if you didn't get out of his way. You know. And they come after revenge. Mark Martin was the class act. He was a guy that was very respectful to everybody, and he'd drive his wheels off and make you earn it if you wanted. Otherwise, he'd beat you because he's Mr. You know, if his car was on, his team was right, they were pretty doggone consistent. And he was tough. He's my favorite driver. Them old boys are all gone. The Allison boys, Richard Petty, all them old boys. And I just can't get into these new crop people.
But between Joey Logano and Kyle Busch, they try to wreck everybody, and then they wrecked each other a couple weeks ago.
Yeah, and kind of got in the fight.
Yeah, but didn't get fined or nothing. And one of them, the week before, had a loose wheel or something, and they fined him $30,000.
But when you go, that comes off, you're not just going to wreck yourself. A bunch of other people could get hurt.
Yeah, it was like a loose lug nut or something. But it was like still, the wheel wasn't really loose. It was just like a loose lug nut.
Oh.
But they're cracking down.
I'm glad nobody got fined.